Hello friends, today we will be studying about surds. Surds is exercise 2.3 of your textbook. So what are surds? So this sign that you know, okay, this what we generally call as the square root sign, it is known as the radical sign. So wherever this radical sign is coming, then it is known as a surd. It is known as a surd, okay. So now this is how generally we write, okay. For example, if we are writing okay, so this is 3 to the fifth root of 3, okay. So this number whatever comes here, it is known as the order of the surd. This is known as the radical sign and this is known as the radicand, okay. So this is how it is, okay. So we'll look at some examples of surds. So what we saw, wherever there is this sign, the radical sign, it is a surd. So these are our surds. Root 2, root 5, root 10, all these are surds. All you can see, these are surds. But if you see carefully, root 9 is not a surd. It just looks like a surd. Means what? If we solve root 9, what do we get? Root 9 is equal to how much? 3. So is there any radical sign here now? No. So root 9 is not a surd. It just looks like a surd. This root 16, it is also not a surd. Its value is 4. Here also root of 100, which is 10. Okay. And cube root of 8. So 8 is 2 into 2 into 2. So it's cube root of 8 and that is 2. So hence all these 4, they just look like surds but they are not surds, okay. Now coming to the next topic, that is simplest form of a surd. So suppose for example this surd is given to you, we will look at these first. Root 98. So 98 can be written as 7 into 7 into 2. Now 7 into 7 we just group them, okay. So what is the order of the surd? It's 2, okay. So whenever the order is 2, we make groups of 2. Suppose the order is of 3, we will make groups of 3, okay. One more thing, whenever the order is 2, it is known as a quadratic surd, okay. They can ask you for MCQ questions. So please remember, whenever the order of surd is 2, it is known as a quadratic surd. So hence this is a quadratic surd, the order is 2 and whenever it is 2, we don't write it. If it is 3, 4, 5, then we will write it. So we make groups of 2. Now 7 into 7, 1 7 comes out and the 2 remains as it is because it does not have a partner, okay. So this is known as a simplified surd of root 98, okay. Similarly, if you see root 48, 48 can be written as 16 into 3 and we all know square root of 16 is 4. So this 3 doesn't have any partner, so it becomes 4 root 3, okay. Similarly, if you have a big number like for example root of 600, so how do we do it? So you can either do prime factorization, this is what you know, okay, this is how you can solve, or how you are supposed to do. You know this is 600 is 6 into 100, that is 6 into 10 into 10. So 6 into 10 into 10. This is how you should be able to do. Now we write all the similar ones together, means 2 into 2 into 2. So all the 2's together, all the 5's together and this 3 here, okay. So now 2 into 2 will make a group, 5 into 5 will make a group. So the 2 will come out, the 5 will also come out. 2 into 5 becomes 10 and this 2 and 3 together will get multiplied and it will become 6. So the answer is 10 root 6. Hope everybody has understood. Now let's move to like and unlike surds. Like surds means when this part is the surds part, the radicand is the same, okay. So here 4 root 2, 7 root 2, 12 root 2, these are like surds, okay. 5 root 7, 12 root 7, these are both are like surds, but 12 root 7 and 5 root 5, they are unlike surds, okay. 12 root 2 and 5 root 7, they are also unlike surds. Clear? Now look at these. They seem to be unlike, but they are like. How can we do that? So root of 27. 27 can be written as 3 into 3 into 3. So it becomes, after solving, it becomes 3 root 3. So therefore now it is 2 upon 3 root 3, and here also 3 root 3. Therefore they are like surds. Okay. Let's move towards the exercise. So the first question of your exercise, state the order of the surds given below. So the order is whatever number is here, that is the order. So here it is 3, here it is 2, here it is 4, here it is again 2, and here 3. State which of the following are surds and justify. So this is a surd. Is this a surd? No. Why? See, 4th root of 16. Okay. Now 16 can be written as 2 into 2 into 2 into 2. Okay. In short, 4 into 4. Now here the number is 4, so we will make groups of 4. The whole 2 will come out and nothing remains inside. So it is only 2. Hence it is not a surd. It only looks like a surd. Next, 5th root of 81. Now we try this with 81 again. 81 is 9 into 9. So we can write it 4 times 3. But this is the 5th root. So we are not able to make the group. Hence nothing can come out of the radical sign. Therefore it remains as it is, and it is a surd. Okay. Now we will move to question number 3, which says classify the given surds into like and unlike surds. Okay, now we have root of 52 and 5 root 13. So root of 52 can be solved further, that is 4 into 13. So 4 can be written 2 into 2, it becomes 2 root 13, and this is 5 root 13. Now they are like surds. Okay. Next, root 68, if you can solve it, it becomes 4 into 17. The 2 into 2, the 2 will come out, it will become 2 root 17. But then here it is root 17, here it is root 3. Therefore they are not like surds. Okay. Question 4 is about to simplify the following surds, which you should be able to do on your own. Okay. You have to just simplify them like how I have taught you. This can be written as 3 into 3 into 3. Okay. And so on. So question 4 you have to do on your own. We will move towards question 5, wherein we have to compare both the surds. Now 7 root 2 and 5 root 3. We have to compare them. So now how this 7 has come out? First it was inside, there were 2 7s, we brought it outside, isn't it? So now again when it will go inside, what will happen? 2 7s, correct? So 7 root 2 is nothing but 7 into 7 into 2, that is root 98. We are doing exactly the opposite of what we were doing some time before. Okay. Next, 5 root 3. So how does this 5 come out? When there were 2 5s inside the radical sign, the 5 had come out. So again if the 5 goes inside, what will happen? 2 5s. So it will become 5 into 5 into 3, that is 25 into 3, that is 75. Now which one is greater? Obviously this one is greater than this, because we can compare the surds when their orders are same. Now the orders are same and there is no other number here. Okay. They are pure surds, so we can compare them. So as this is greater than this is greater than. Clear? Let's move to the next one. 5 root 3 and 9. So now 9 can be written as square root of 81. 9 can be written as square root of 81. Okay. And 5 root 3, the 5 goes inside and it becomes root of 75. So obviously 81 is greater than 75. So 9 will be greater than 5 root 3, or you can write it in this way. Okay. Next we will look at addition and subtraction of surds. One important thing I will try to like to tell you is, whenever we add or subtract surds, they should be like surds. Otherwise we cannot add them. You cannot add 5 root 3 plus 2 root 2. You cannot add them because here it's root 3, here it is root 2. They are not like surds. You are not allowed to add them. So we can add only like surds. So now these three are given to us. Are they like? Let's see. Now you have 7 root 48. 48 can be written as 4 into 4 into 3. Correct? 16 threes are, or whatever tables you know, according to that you should be able to break it up. Or you can do prime factorization. Next, root 27 can be written like this and root 3 as it is. So now we make groups of 2 because the order here is 2. So 2 into 2, 2 into 2, this 2 will come out and this 2 will come out, it will become 4. Okay, this 3 will come out, it becomes 3 root 3. This as it is. So it becomes 28 root 3 minus 3 root 3 and this. Now we take root 3 common. We have 28 minus 3 minus 1. Correct? So it becomes 28 minus 3 minus 1 minus 4. We get 24 root 3. Is that clear? Next, fourth question, a little bit tricky but nothing tough. This is given to you. Now we take the root 7 common. Okay. Now here nothing means it is 1, correct? The coefficient is nothing means it is 1 always. So it is 1 minus 3 root 5 plus 2. Now we take LCM. So those who don't know about LCM, please look carefully. Here the denominator is 1. Here the denominator is also 1. So we multiply the denominator by 5. So the numerator also gets multiplied by 5. So it becomes 5. This 3 remains as it is. And this 2 again we multiplied by 5 because here it was 1. So into 5. Now 5 here, 5 here. Okay. This is how we take. If anyone is not able to do LCM, please contact me. I will teach it to you in a separate video. So after doing LCM, we have got this and hence we solved it. 5, 10, 10 plus 5, 15, 15 minus 3, 12, 12 upon 5 root 7. Okay, it is easy. Now let's see multiplication of surds. Multiplication of surds can be done even if the surds are not like surds. Okay, so this is given to you 3 root 12 into root 18. So we first simplify it so that our work is easy. So 12 can be written as 2 into 2 into 3. So the 2 comes out, root 3 remains. This can be written as, it's 2 into 9. 9 is 3 into 3. So now this 3 has come out. So now here you have got 6 root 3 into 3 root 2. Okay. Now we multiply the integers 6 into 3, the numbers 6 into 3, 18, and then the surds, root 3 into root 2. The order remains the same, 3 into 2, 6. Okay. One more question we can see, one more way of doing it. One more way is, this is given to you, 3 into 7, 21 as it is, and we just multiply the roots as it is without simplifying them. Okay. So 12 into 15 is 180. Now 180 you have to break down into the prime factors. Now once this prime factorization is done, write it down wherein all 2's together, 3's together and 5. Then 1 2 will come out, 1 3 will come out. So it will become 21 into 2 into 3 root 5. So it is 126 root 5. Okay. Now division, which is very easy. Numbers will be given to you. Just you have to divide it, 310 upon 5, whatever is the answer. You will be able to do it on your own. Let's come to the last question of today. Rationalize the denominator. Rationalize the denominator means take out the radical sign from the denominator. You don't want this root sign in the denominator. Only that you have to do. Now how will you get rid of this root sign? So when you multiply root 5 again with root 5, the root sign will go away, because root 5 into root 5 will give you 5. Okay, anything root 2 into root 2 will give you 2, in that way. So we multiplied with by the same number, so it's root 5. So if you are multiplying the denominator, you have to also multiply the numerator, so that it is balanced. So we just into root 5 upon root 5. Okay, so now root 5 into root 5 becomes 5, and this becomes 3 root 5. This is the answer. Next question, if you see 6 upon 9 root 3. Now understand one thing very carefully. This is our enemy, only this fellow is our enemy. We have nothing to do with the 9 or the 6 or anything. We have to just get rid of this fellow. So now what we have to do again? Only multiply by root 3 root 3. Okay, so root 3 into root 3 will become 3. Okay, and this will become 6 root 3. This 6 and 3 you can cut, 3 ones are, 3 twos are. You can also cut this 6 with the 9 if you want in the first step itself. So you will get the same answer, that is 2 upon 9 root 3. The remaining questions which I have not done in today's video, students are expected to do it on their own and finish the exercise. Thank you.